This IXL is going to go IXL CC3 LZF. I am going to do 2 examples in the IXL to help you reference should you need some help. All right, so the first thing it's going to ask us is the function linear or exponential? So a way that can help you is linear, oops, sorry. That's not a line that I was going for at all. Okay, if a line is linear, that means that something is being added or subtracted every time on the y value. If it's exponential, that means it's being multiplied or divided. So all you have to do is figure out which one and it will tell you if it's linear or exponential. So 2 to negative 6. So 2 different things could have happened. We could have subtracted 4 or we could have multiplied by 3. We're not really sure what's happening, so let's try either one. How did we get from negative 6 to negative 18? Can we subtract 4 again? No, because that won't give us that. But we could also multiply that one by 3. So that one looks like it's working. Let's just make sure it works again. Negative 18 times 3 is negative 54. So because you are multiplying every time, it's exponential. All you have to figure out. So let's try another example. So again, linear is add or subtract, and exponential is multiply or divide. Okay, so to know if it's linear or exponential, so how did we get from 2 to 6? Oh, these are the same numbers in this example. Sorry, how did we get from 2 to 6? We could have added 4, or we could have multiplied by 3. How did we get from 6 to 18? We're also multiplying by 3. So because we are multiplying, it's exponential. I guess I can throw in another example real quick. So if I have x and y values, and my x's are 1, 2, 3, 4, and 5. So what I want to look at is my y values. So let's say I gave my y values to be 6, 8, 10, 12, and 14. So now I have to figure out what happened between these. So from 6 to 8, I added 2. There's not really anything I can multiply necessarily to get from 6 to 8. And then I found out here I also added 2. So because I am adding every time, adding is linear.